please help Kevin first. Please make sure you keep Mercy Rewe on the line so that she knows in the next 15 minutes she will be on.
So protocols observed, fellow researchers, good afternoon. I'm Kevin Obondo, and I'm grateful for the opportunity to present my findings on quality of water hyacinth compost and their likely effects on soil properties and crop production. I am a Master's of Science in Soil Science from Egerton University. Welcome. So our soils have a general trend in decline in fertility as a result of continuous cultivation, and this one cuts across the sub-Saharan Africa. And due to this decline, production has become nearly uneconomical without the use of amendments like fertilizers. And so most of our farmers has gone or relies on chemical fertilizers as alternative sources of soil amendments to improve productivity. But due to as majority of our farmers are small scale and are low resource endorsed, you realize that in most cases we apply the fertilizer in the low amount compared to the recommended rate, and as evidenced by a decline in production per unit area, especially for the high value crops or food crops, which are staple like maize, especially in the Lake Victoria region. As a result, there have been so many research conducted on different ways in which we can be able to enhance fertility. One of them is based on the use of organic amendment as alternative to chemical fertilizers, which are very expensive and most of our farmers cannot be able to afford. And one of the main limitations of now this organic amendment, for example, we have organic amendment like compost, is that the availability is a problem. Why? Because the raw materials required for their preparation have so many alternative uses that they cannot be available for this for that purpose. And so it's the water hyacinth, which has been found to be rich in essential plant nutrients. And so in this experiment, it was taken through 3 composting systems. And why composting system? It is because we understand that organic amendments like compost manure, farmyard manure, they are very bulky. And so most people do not prefer them because it is very difficult to transport them to our farms. And so coming up with a system which will give us a quality organic fertilizer will be of important value to our farmers. So one of the systems is what we refer to as vermicomposting, where we used earthworms to transform organic waste into more viable form on what we refer to as vermicast. Another one is the EM composting technology, where we are using effective microorganisms collected from the natural environment And these organisms include photosynthetic bacteria. We have lactobacillus, we have Saccharomyces, then there's also fermenting fungi. They play a very important role in converting organic waste into economic value product. The other system is what our farmers normally use, which is the ordinary composting, also referred to as thermophilic composting, where you just put your materials, then you rely on the organisms on their natural settings. You find most of our soils, especially in the Lake Victoria regions, they are very acidic and very infertile. And due to this high cost of these inorganic fertilizers, our farmers have tried to their level best, but still they could not manage to reach the recommended rate. And moreover, the quality of compost prepared from water hyacinth has not been well documented. There's no available information on how we can use compost from water hyacinth. Therefore, this present study aimed at coming up with some of the pictorial representation to the solution and the use of water hyacinth as alternative. So the general objective of this study was to contribute towards sustainable agricultural development through the use of compost produced from water hyacinth for enhanced productivity and soil quality improvement. And the specific objectives were to determine the quality of the compost, to see the effect it can have on our soil when we apply it, and also to see the effect it will have on crop production using maize as a test crop. So the research hypothesis matches our specific objectives. So we find that in Kenya, agriculture is the basket contributing to more than 70% of employment and income in the country. And maize production, as an example of our staple food, from the previous finding, it has been found that we cannot produce enough maize to feed our population. Why? Because of some of the challenges discussed in the background. And therefore, if we can find ways, like the use of organic amendments, of improving our fertility for enhanced productivity, it will be of important benefit to our society. So the experiment was carried out in two environments. One was in Asembo Bay, that is in Siaya, Lake Victoria Basin. And another experiment was conducted in Kisii National Polytechnic in Kisii County. So there were two experiments. The first one, which correspond to the first objective, was to determine the quality of the compost. So it was prepared in Asembo Bay. Then the second experiment, which is a confirmatory test, was conducted in Asembo and in Kisii to see the variation. So those are some of the materials that were used in the experiment, and the pictorial represent some of the activities. The first one showing a member of the community-based organization based in Asembo, where the experiment one was conducted, harvesting water hyacinth. Then the second one, some of the members transporting it to the composting site. The third one is showing how the compost was dried. So the next is the compost preparation. Allow me to give you a snapshot on how the process was carried out. So that one shows the profile of how the materials were arranged for the vermicomposting system. We have the whole carpet at the top, followed by the food substrate and the worms. Then we have the sawdust, which act as bedding materials. For more details, we'll talk about later. So those are the red worms which were used for vermicomposting system. Then on the right side are the effective organism. This one, actually, you can obtain it from any agrovet. For ordinary composting, that is also a profile. You can see there's a temperature stick. That one is just used to check whether the composting is going on. Then for the EM composting, that is also the profile. So after composting, the next step was to determine its quality. And the table shows some of the methods and some of the parameters that were analyzed, like water holding capacity using the capillary action technique, the bulk density using the water displacement method, and many others. So after the first experiment, we moved on to the second one, which was now a confirmatory test to see what impact these water hyacinth compost types can have on our soils and on our crops. The field experiment was conducted in a random as complete ball design, and these were some of the treatments. There were 5 treatments. The first one being water hyacinth vermicompost, the second one water hyacinth EM compost, the third one water hyacinth ordinary compost. The fourth one is a positive control where we used inorganic fertilizer or the chemical fertilizer. Then the fifth one was a negative control where no fertilizer was applied. So that was the experimental layout. And soil parameters, soil was analyzed before the commencement of the field experiment and after. And so some of the parameters and methods that were used to analyze them are indicated below. We can discuss that one also later in detail. Of course, there was planting using maize as a test crops, compost being applied at the rate of 5 tons per hectare, and inorganic fertilizer at the recommended rate of 200 kg per hectare. Maize hybrid 517 was chosen as the test crop. The management practices were carried out effectively. Then after that, in the course of the experiment, we also did some plant sampling because we want to know how we can relate the compost application and effect it's going to have on our plants. And those are some of the data that were collected. Maybe if I can stress on some of them, like the harvest index, which was done using the formula above. Then we also do something on nutrient use efficiency, where we had agronomic efficiency, we had apparent nutrient recovery efficiency. We also had partial nutrient balance using the formula.
Kevin, we want you to finish, please.
Okay, thank you. All the measured parameters were also were taken through the normality test using the Shapiro-Wilk procedure, then analysis of variance conducted in RCBD and mean separation using the LSD. So result and discussion. So the pictures represent some of the results. These were for a mature compost. The first one is a vermicompost. The second one is a thermophilic, and the third one is a EM compost. The same temperature variation during the composting system was significant, with the highest being 59.6. We also collected some data on compost maturity, and the one which achieved first maturity was EM compost, followed by the vermicompost. Then the compost were analyzed for different parameters, as shown below. There's also a saying that because water hyacinth grows in a lake, there are high chances that it can contain some phytotoxic compounds coming from the industrial areas. So we took it through a germination test to see whether it contains some chemical that may bioaccumulate to human when we consume the product that come from what we produce using it. And some of those are the parameters which were analyzed prior to field experiment, and those are some of the parameters that we analyzed after the experiment. So to stress on, vermicompost was found to be the most effective alternative to chemical fertilizers, which is economical and friendly to the most farmers. And in the picture below, you can see at the center there, that's where we did not apply any fertilizer. You can see here how it is relating compared to other systems where we used organic and inorganic fertilizer. Okay, so we also did some yield parameters, evaluation, total above ground biomass, grain yield, and harvest index. And the one which is of interest to the farmer is grain yield, and we realized vermicompost was very good. It was followed by inorganic fertilizer in both areas. We also did something on nutrient uptake, and still vermicompost emerged as the best. So from this study, it is without doubt that the use of water hyacinth in compost can be a suitable remedy to the deteriorating soil fertility in the Lake Victoria region. And from our experiment, vermicompost was found to be the most suitable. And efforts that can be put in place to commercialize its production so as to contribute to existing effort in curbing the deteriorating soil fertility will be of important interest. Further studies may be necessary based on our experiment, where we can combine 2 or 3 systems and see how it's going to work. Initially considered as an noxious weed in the water, I can confidently say that water hyacinth is a future gold in the water, that everybody is going to struggle to get a piece to make use of it. Thank you very much for listening.
Thank you. You have gone beyond my time. And so we only have one burning question, if there is. Silence means they were listening. And the questions will be in the chat.
Thank you.
Thank you very much. Let's get the online presenter, Rewe. Is she connected?
Yeah, good evening. Just allow me to share my screen. Share screen.
Go on, Mercy.
Yes, Mercy, yeah, it's me. I just wanted to share my screen so that I'll be able to present.
Mercy, are you okay? Oh.
Yes,
I
yes,
think
please, I am right here.
we are not seeing the screen.
Yeah, that's what I'm trying to share. I'm trying to exit, minimize screen. Oh, I shared, but I don't know what happened.
Go down try to go down the screen and click share screen.
Yes, I clicked on that, then I clicked on the presentation itself.
We are seeing just your folder. I think it's not open yet.
Oh, it's not open yet.
You have shared your file folder where the document is. Can you double click the
Okay.
document? Open the document first before you share. Just click the document and see you have it on the screen.
Okay.
Or what you do, just stop sharing first. Open when you have stopped sharing, go to your folder, double click your document and make sure it's on the presentation mode first.
Oh, presentation mode. Okay, let me put it on the presentation mode.
But close this one we are seeing. There is something we are seeing.
Okay, sorry about that. So I need to save.
Okay, click where the sharing is and click stop sharing.
Okay.
Have you
Stop
seen?
sharing?
Yes.
Yes, I clicked on stop sharing. Now I share again.
No, now open your document first.
Oh, okay.
Open it until you see it yourself.
Yes, I see it, please.
Are you seeing your PowerPoint on your computer?
Yes, please.
Now go down and click share.
Is it
Give it a few minutes, eh?
Now,
Now we can see.
is it visible yet?
Yes, just go on.
Okay, now you can see. Thank you very much, and thank you very much for your guidance, and sorry for the delay. This issue of technology. My name is Masurewe. I'm a PhD student at Pwani University, and I am going to present to you just one of the objectives from a study. And this objective was trying to look at the possibility of using bioslurry as an alternative to inorganic fertilizers in increasing soil fertility.
And Mercy, just a minute, eh?
Yes, please.
In the benefit of time, we want you to focus on the objectives and then the methods and then what did you got. We have only 12 minutes for you.
Okay, Sam. Thank you very much. That's one I've noted. So we will not go through the background actually because my predecessor has just discussed it, and I'm now looking at bioslurry. My concern is bioslurry, and as we are aware, bioslurry is actually a byproduct of anaerobic production of biogas from organic waste. So I want to look at the objective that we had. We wanted to study two different biodigester types, and wanted to see the effect of bioslurry from the two biodigester types, that is flexi and fixed dome, on as well chemical properties. But we also wanted to understand what happens when that bioslurry is integrated with inorganic fertilizers on the stem. So that's why it was done in our Royal Agricultural Training Center in Kiambu. So basically, this is just a graphical presentation of how it was, but these are the treatments. So in our treatment, we used 100% bioslurry from either biodigester types, and then we varied the bioslurry to 75%, and then we added, topped up with 25% inorganic fertilizer, then we moved down to 50, and then we had 100% fertilizer, and then a control, and it was all laid out in a randomized complete block design with a split plot arrangement and 3 replications. Now maize was used as a test crop. So soil sampling was done before planting and after the 2 seasons of planting. So this slide here shows the effect of use of bioslurry from the 2 different biodigesters on soil chemical properties compared to the initial. So if you look at it, you'll notice that those boxes present where that element was highest after the 2 seasons. The second column is the initial, and generally there was an increase. There was an increase in these chemical properties when bioslurry was used, whether it is dome or whether it is flexi. But except actually where we had magnesium or magnesium, the decrease was actually in magnesium. Something happened here. It was magnesium and calcium. But looking at it, we had higher nutrients. We had higher nutrients when dome bioslurry was used compared to flexi, as you can see there in the boxes on the column and the dome. And this could actually be explained by the fact that the dome bioslurry, or rather the substrate, is not completely digested when it is used in dome. So it means that there is further composting that goes on in the field, and compared to flexi, where it is assumed that there is complete digestion that takes place in the biodigester. And this can also be supported by the fact that the analysis of bioslurry from both biodigester showed that the nutrients were much higher in flexi compared to DOM. Now, this one table here is talking about the effects now of the treatments, the 5 treatments you've seen on various soil chemical properties. This one is about pH and exchangeable acidity. So when you can notice that all the treatments increased the soil pH except where fertilizer alone was used. There was a decrease, but the others, including control, there was an increase. And when it comes to the exchangeable acidity, the effect was almost similar because they are interrelated. There was a decrease in exchangeable acidity when bioslurry was used, except now where about higher levels of fertilizer, that is 100 and also 50, were used where the exchangeable acidity increased. Now, we can say that the reason for the increasing soil pH with increase in bioslurry levels is because the base cations, the base cations were high in the bioslurry, but at the same time, the bioslurry was alkaline. And when it comes to the fertilizer, the increase, or rather the decrease in soil pH was basically due to nitrification as well as uptake by plants. Now, this table here gives us a presentation of the effect of the treatment on the macronutrients. So generally, as we have said, there was an increase in these soil parameters when the treatments were done. There was an increase except on calcium as well as magnesium. Magnesium, actually, there was a decline from the initial. When all the other treatments were made, the levels went down. For calcium, there was either a decline, or there was a leveling, or there was an increase. But now, if we look at the total nitrogen and the total organic carbon, use of bioslurry, and especially higher levels of bioslurry, contributed to higher contents of those 2 elements. But notably, the phosphorus and potassium were highest when fertilizer was used. But you can see that those two, total nitrogen and total organic carbon, as well as calcium and magnesium, were higher when either bioslurry alone or its integration with the inorganic fertilizers were used. So this is for the effect on micronutrients, and it's actually the same. If you look at manganese, copper, as well as zinc, there was the highest increase was when either bioslurry or its integration was used, although iron and sodium was highest in control. Now, it was noted that there was a correlation between the total nitrogen as well as total organic carbon, where both increased concomitantly, and this could be as a result of the fiber, or we can say the organic matter content that is usually higher in that was found to be high in bioslurry. And when it comes to the P as well as K values, these were higher. They were high. They were actually rated as high before and also after the treatment. And for the P levels, they are high because they have low mobility. And actually, it's not every P or phosphorus that is added to the soil that is utilized by the plant. But also considering that we have organic matter in terms of bioslurry, then it also means that they provided higher levels of adsorption sites that ensured that the nutrients can remain within the soil longer. Now, we know in calcium, but magnesium, we found that it declined generally, and this could be as a result of leaching. But at the same time, magnesium is not usually very strongly bound to the exchange site, so it is easily dislodged and hence lost through leaching. So this is actually a picture of the experiment site. And if you look at it, actually, it's not difficult, it's not easy to differentiate between which treatment was which, except for control, for sure, it is possible that help to improve soil, can help to improve the chemical properties of soil. In that, it raises the soil pH, but also it supplies plant nutrients and creates a better environment for availability of these nutrients, because it contributes positively to the soil structure, the soil texture, the soil physical, as well as biological properties. And because there is an issue of disposal, so it can actually be utilized in the farm. As recommendations, it is important to have a longer term experiment that will help us to understand better the long-term effects. But actually, the experiment was carried out in an area where there are usually so many other experiments that are carried out. The soils were not very deficient of nutrients. So it would be interesting to know what happens if bioslurry is used in a farm, in a normal farmer's farm, where nutrients may not be in very high levels. And also, we did not look at the effects on soil physical as well as biological property, which would be interesting to know. And we only used about 400 milliliters of bioslurry per hill. So what would happen maybe if higher levels were used? So that is it. I tried to really rush through in the interest of time, but thank you very much for listening.
Thank you, Mercy. We want to thank you and clap for you. Mercy, just stand in there. We want to ask one or two questions very fast. Any burning question? Two. I have one here. I want one there. Okay.
Okay, thank you, Mercy, for the presentation. I know I'm not a pure agriculturalist, so some of the things were floating. But looking at your recommendation, because I was about to ask the question, but then I saw it in the recommendation, wouldn't it have been also wise to find out on the level of impact on the other environmental factors that you mentioned in your recommendation? Because I felt that then they have a great impact on the outcomes that you have, and you may not be able to exclusively allude to those results, to the bioslurry that the plants were experimented on. Thank you.
So I think that's a comment. You can consider it. So
Okay,
we want. Thank you, Mercy, and we now, if you can still stay here and continue listening, it will be happy until your bundles goes off completely. Now I want to return it to Dr. Pondo, and before I return to her, I'm a noisy person. There is no way you can just come from lunch na mmekaa tu chini. Can you stand and we clap for those who are present and even those who chaired in the morning, isn't it? And you shake a bit, eh? Yeah. Hey, looks like a class. Hey, you guys are serious. Please look at the sides, your side, and what do you see? Some human being, isn't it? Just say, God is a very great person. If he created somebody like this, can you do something like that? So God is important, isn't it? Thank God for that. And then let's clap for those. Nani anajua nyayo? I'm sure many of these professors know that. You say nyayo, huh? Walikuwa nasema tingiza, isn't it? You tingiza paka you shake. So let's shake for them. Nyayo. Nyayo. Mbua. Karibuni. Sekondo karibu. Thank you.
So thank you very much, Prof, for the moderation, and thank you, Edwin, for the great job. So I welcome Dr. King'ao to take us through the next session, and he will be assisted by Dr. Clement Achimba. I'm really enjoying the presentations. I don't know whether you people are equally enjoying the presentations. And tomorrow, I request that we stop crowding on this side, so that we can be distributed across the hall. It seems like people really love this side. They want to flock on this side. So kindly tomorrow, let us try and distribute ourselves even to this other side. So welcome, Dr. King'ao and Dr. Achimba.
Thank you very much. I think we'll go straight to the presentation. And I want to welcome Okwala Mayabi to start off. That's from Egerton University. So we'll take a very short time, and because of a time factor, we'll give each presenter 10 minutes and 5 minutes for additional either queries or other remarks. So it's still your part of your time, the 15 minutes. So I want to welcome aboard Mr. Okwara to take us through his presentation. Welcome.
Thank you, Dr. I'm Okwara Wilberforce from Egerton University. Since morning, everyone has been talking about food, but you have not asked yourself, how do you prepare that food? That's why when I come key into this hall, I'll be talking about the effect of process parameters and feedstock on briquette qualities. My supervisors is Dr. Engineer Kabok from Jaramogi and Dr. Caroline Maina from Egerton. Statement of the problem: actually wood fuel is the main source of energy in Kenya, regardless of emission that is released from burning of those wood. But then biomass is generated in bulk and cause environmental problem. And this biomass can be utilized in briquetting. However, briquettes made from one feedstock have shown very poor characteristics, but briquettes from two feedstocks have shown improved characteristics. However, we do not know, or little is known about briquettes with more than two feedstocks, their effect, and so on. The broad objective of this study was to evaluate the effect of process and feedstock parameters on briquette properties. To attain that, I had to look on specific objectives. Number one was to determine the optimal combustion properties of briquette based on mixed ratios, determine the effect of selected briquettes on performance properties, then to determine the effect of emission released from briquettes compared to Checo. And that was my main aim, this specific objective number 3. Justification. Growing energy demand actually is one of the major challenges facing the world today, but through the understanding of engineering agglomeration properties, waste can be minimized through alternative uses, and that's by briquetting. So briquetting will reduce the increasing energy demand and emission released from wood. Sustainable Development Goal, SDG number 7, will be attained through that. Actually, scope and limitation, I was mainly interested in 3 feedstock, that's rice husk, corn cobs, and sugar bagasse. The reason as to why I chose these 3 is because they can be found at one located point, that's Kisumu. We can find corn cobs from just local farmers, rice husk, Ahero, bagasse, Muhoroni. Mixed ratios, you can see we have 9 mixed ratios. That's because we have 3 feedstocks, and using Taguchi technique, if you have 3 parameters, each parameter can be varied in 3 levels, meaning you'll have 9 mixed ratios. Actually, technology I'll be using drum kiln that I fabricated and drum agglomerator that I used in Awaskol, Nakuru town. Properties I'll be checking at combustion, performance, and emission release from these briquettes compared with charcoal. This is the experimental kiln design. Actually, it's just part of it. This is the burning part. I extracted the condensation system. I know people from environment who tell me burning feedstock releases a lot of smoke. I took that into account, and I had to add there a condenser where I condensed the smoke used by people from agronomy. So this is just the kiln, drum kiln. Optimization, that was specific objective number 1. Actually, let me go straight to results and discussion. Objective number 1 was optimization of combustion properties of briquette based on mixed ratios. I wanted to find out from these 9 mixed ratios, which mixed ratio was best to use as a fuel. And for any material to be assumed to be a fuel, it has to have ash content, that's AC, of less than 7%, volatile matter 20 to 30%, fixed carbon more than 75%, calorific value, which is the main component, more than 20%. Yes, you can see all these mixed ratios are having calorific value of more than 20%, but then we cannot assume other factors. Therefore, we had to look into fixed carbon. Looking at fixed carbon, we'll eliminate nearly all except this 3:3:1, the last one, second last, and I think the 4th from bottom. What can you tell? The mixed ratio was in rice husk, corn cobs, and bagasse. As bagasse is reducing, you can see fixed carbon increases. Maybe we can say after you have carbonized the feedstock, you cannot bond them into briquette directly. So you have to add a binder. Molasses was used as a binder. Molasses comes from sugarcane, and we are again using bagasse. Let me hope you are getting something. Molasses is non-combustible. That's, I think, the reason as to why if you see bagasse increasing, fixed carbon is reducing. That was specific objective number 1. Discussion is everything that I've just said. Specific objective number 2 was to look at the performance characteristics. When you are looking at performance characteristics, actually, we are looking at time to boil, burning rate, specific fuel consumption, and power output. Actually, in performance of briquette, I had to check in 2 tests, that's cooking test and water boiling test. I measured in water boiling test, where I had to take higher power phase that include cold start and hot start, then low power phase that deals with simmering. Time to boil average was 14 to 14.5 high power phase, which is okay because it's recommended that time to boil should be between 14 minutes to 20 minutes for domestic cooking. Burning rate was okay, 24 grams per minute. From table 4.2, actually that one I've already said, burning rate increased from cold to hot start, and that's because increased temperature in combustion chamber, since the hot start began after cold start when the GECO was still hot. Specific fuel consumption based on calorific value of the fuel was greater than recommended, 0.02 megajoules per minute. That's according to ISO IWA 2013. My main interest was here, effect of emission released from briquettes compared to charcoal. Actually, we are doing ourselves a lot of harm using this charcoal. You can see from the results that I obtained, first, briquette I had to use 0.68 kilogram, and they burned for 3.7 hours. We only needed 0.75 kilogram to burn to cook amount of meal. Okay. But in charcoal, we needed 0.55 kilogram to burn for only 2 hours. That was not even the interesting part. Come to emission released. When you use briquettes, actually, the average indoor air concentration was 94.7 ppm, that's CO2. And in CO was 15.5. Then particulate matter, that's 0.03. But emission that were released after using those briquettes, CO2 was 1,065.5, CO was 110, particulate matter was 0.18. Now look at the charcoal. CO2 was, at first was 243.2, even more than double the briquettes. CO was 62, and particulate matter was 0.41. But the emission released after burning of this charcoal became 1,670.4, 270.5, and particulate matter was 0.95. In discussion, briquettes emitted the lowest amount of CO2, CO, and particulate matter as shown above. Actually, there was a significant difference of 95% in emission between the two fuels. Emissions were reduced by more than 50% when you use briquettes than charcoal. Then, although all the fuels had calorific value more than 20 megajoules per burning time differs significantly. Conclusion, actually, bagasse mass fraction had dominant effect on all property investigated. Then performance properties of briquette was significantly affected by type of biomass. And then number 3, recovering biomass for briquette production contributes to additional fuel that greatly reduce greenhouse gases and deforestation. Recommendation, actually I recommend number 1, several biomass to be tested with different mixed ratios and the calorific value known to substitute charcoal. Number 2, comparative study on performance of different biomass fuel types with same ratios to be done. Then last one, alternative fuel source to be established to replace this charcoal to reduce indoor emissions. These are some of the references that I used in my work. And this the drum kiln that's found in Nawasco that I used to make those briquettes. Thank you.
Thank you very much, Mr. Okwara. You have just used 11 minutes. You have 4 more minutes that we can be able to interact with the audience. So we want to request for some questions. At the same time, you can post your other queries on the chat. 1 or 2 questions? Facilitator, please walk the mic fast enough.
Wilberforce, that is excellent.
Thank you, Prof.
Creative and also useful. What I wanted to know is, you know those technologies,
Yes.
in terms of the waste is available, but what you used, that machine,
Yes.
you know, you need something that goes immediately to farmers. We want research that is ready to go. Now you are saying this item is available somewhere. How much? I'm a money person, eh?
Yes.
How much, how available, how easy accessible, how easy usable by farmers, eh? So that you can sell this thing immediately.
Okay. Just to answer that question.
And then, no, the last one on that. You see, the language is academic, I know. Think about how you convert this thing into easy. You tell them, you know, you are talking about calories, eh? I don't know, technical words, eh? CO2, what. I think you should find a way also of transforming it easier.
Yes.
I'm thinking about the user, but it's very good information.
Thank you. Maybe to...
Thank you very much. I just have a concern on this preparation of briquettes. I think we are going to use, the smoke will be emitted.
Yes.
And that one start contributing to pollution of the environment vis-a-vis will affect the issue with climate. So, if that, so how can you reduce that emission of that smoke so that we try to conserve environment as we try to adopt these technologies? Then again, we are going to use firewoods for us to heat these things and we get the product. Either you are going to use the natural plants. Some are medicinal, or the fruit plants. So how can you minimize, or which kind of energy you propose for your study to use to avoid effect on the climate? Thank you.
Let me begin with him. Thank you. Actually, if you are very keen, I said, on that carbonization kiln or drum kiln, I extracted the condenser, where I said that the condenser was used to condense the smoke that was produced during carbonization into liquid form. That liquid form, actually I did not want to go into that much because agronomists are there. I said that liquid can be used either as a fertilizer or pesticide. It only depends with the ratio in which you are mixing with water. If you mix it with 1:50, I think from literature 1:50, it goes to fertilizer. If you mix it 1:100, it goes to pesticide. Thank you. Prof, you are talking about availability of drum agglomerator. Actually, the one I used at Nawaskol was when I was still taking my results. After that, university saw the project in which I was taking, they are more interested in it. We have made more of this drum agglomerator. I think next month you are going to Baringo. You have heard of Madenge plant in Baringo. Give me 1 year, it will be normal. Thank you, Prof.
Thank you very much. Let's give him a hearty clap. So at this juncture, I want also to invite Rangat Nicholas to take us through the screening of ZMAs in 10 minutes as usual, and the 5 minutes for interactions.
Thank you, Chair. I'm Nicholas Lagat, a PhD student from Ecrlf Conference. I'm going to present phenotypic screening for gray leaf spot disease in maize.
Maybe you get nearer to the mic.
I'm going to present this part of my objectives, objectives, phenotypic screening of gray leaf spot resistant in maize, inbred lines in Kenya. Worldwide, maize is among the leading crop in terms of grain production. However, production is constrained by a myriad of diseases, and these diseases range from fungal, viruses, and even bacterial diseases. And in Kenya, especially in Western Kenya, diseases are mostly predominant. This is because of environmental conditions that are conducive for development of many diseases. That's a pictorial of a GLS disease. And the question comes, why do we need to manage this GLS disease? Why do we need to control this type of disease? One of them is to prevent economic losses in terms of grain production. You find that this disease affect maize mostly during flowering stage. And thus, it affected the grain productions. So, one of the things is that it reduces the yields. In terms of grain production. It increases the production cost. When we say production cost, we talk in terms of control measures, because most of the farmers use chemicals, which are costly to them. Also, poor quality of grains. You find that this disease affected the grain in terms of lodging. And secondly, it guarantees food security. You find that one of the pillars, the 4 pillars of the government, is the guarantee food security. So, in reduction of yield, you will find that the food security won't be there. These are 2 pictorial of 2 regions, 2 agroecological zones. One is on higher elevation, and the other one is on lower elevations. So, Kakamega is one of the regions that is under low elevation, and Egerton is one of the regions that's high elevations. So if you can see the pictorial there, you find that the disease density or the disease pressure in Kakamega is higher compared to the Egerton. Maybe later on I'm going to explain why the disease pressure is higher on the lower elevations. My objective was screening and selection for disease-resistant genotype for incorporation into breeding program. You find that in breeding, screening is a preliminary step in selecting a resistant variety, especially when you are dealing with a disease. So you must do screening. And when you do screening, you must do screening on a very many genotypes, very many lines, so that you select a few that you'll propel them to the next stage of breeding cycle. And collection of phenotypic data through appropriate scoring scale. I will explain the scale I was using. And methodology, stage of disease screening, first of all, you need screening and selection of parents. And that's why I say you need a very wide lines so that you come up with the best. And then identify a good source of resistance for use as a donor traits. That's done in nursery development, and I was able to do it in Kakamega, and F1 screening. So you can do F1 screening per C crossing, where you combine crossing at the same time. You are able to do screening. This is useful for you to, maize take longer time. So you reduce the cycle of breeding. Preparation of inoculum. Samples were collected from 3 counties in Kakamega, in Western Kenya, the Western Province. That was Busia, Bungoma, and Kakamega. And most of you will ask, why 3 counties? The GLS disease has 2 strains and is affected by environment. So you can find that the strain in Bungoma or Busia is not the same as the strain in Kakamega. So I was able to collect them, the 3 locations, so that I can bulk them together. So the selection comprises of farmers' field, the research station, and trial sites. How do we do inoculations? You find that when you are dealing with the disease, you can do it naturally or you do artificial inoculations. So in my research, I did artificial selection where the collected leaves were grinded or milled into pottery form, and then I was able to introduce into plants, maize plant, into a midrib, that's the funnel part, the upper part. And I was able to repeat it 14 days after the first inoculation, so that you are sure that those plants that were not able to be inoculated are inoculated lastly. Data collection, I did data collection on yield components, as shown on my screen. And the disease, the scaling of the disease was between 1 and 9, where 1 is the resistant variety and 9 is the most susceptible variety. This scoring was done according to the CIMMYT scale and Carroll Kakamega. Data analysis. The data was analyzed using Darwin software, version 6.
If you can go to the results.
And dendrogram was constructed. When we come to results, you can find that out of 45 lines, there were selected lines in Kakamega that show resistance according to table of means. I was not able to put table of means, but using the table of means, I was able to construct a dendrogram tree where it groups these varieties into different groups according to their resistance levels. So you find that like variety KTL Mills, Kakamega lines, it was able to be ranked the first one in terms of resistance level. When you come to dendrogram, that's a dendrogram tree, you find that that dendrogram was constructed out of table of means, and it grouped these genotypes according to their levels of resistance. So you can find those who were resistant were ranked in one group, and those who were not resistant were ranked in another group. This is very important because it informed the choice of selecting your variety for a breeding program, so that you cannot transfer the old varieties, for example, 45 lines, into the next level without doing anything. So this was very interesting in selection of those genotypes. And I had said earlier that the study was done under a stress environment, because you do it under a stress environment because these are conditions that farmers encounter daily. So
You have 1 minute to finish.
when you are doing breeding, you do it in a stress environment. In Egerton, it was even very interesting because you find that varieties that was run, the first one in Kakamega, in terms of resistance, were not resistant in Egerton because of environment, genotypes, and host resistance. And that one shows us that a dominant effect is very important when you are doing a breeding, because a resistant genes can be silent sometimes. When you take it to a favorable condition, it shows up. And that's why dominant effects is important. That's again dendrogram of Egerton. And another very important point I want to stress is that apart from dominant effects, we have additive effects in plants. When I talk of additive effects, after crossing, the genes can be transferred from one plant to another, and it gives even a stronger level of resistance. Conclusion is that I was able to select the lines that were resistant, and I took them to the next program. And another conclusion is that in my study, it revealed that environment contributed a lot in variation of these genotypes. So what does it mean? It means that during screening for resistance in diseases, you must consider the environment. I would like to acknowledge the World Bank through the Center for Excellence for giving me this chance. I'm also grateful to Professor George Award, Director SISAM, for supporting this program. Lastly, my supervisors, Professor Woche and Dr. Ohio, who provided a lot of comments and suggestions in these presentations. Thank you.
Thank you very much for that, Nicholas. I think the issue of screening of resistance to reef spot disease. Now, we have about 2 minutes because you have exceeded your own time. 2 minutes for reactions, additions, and others. At the same time, I will encourage Florence to be ready from Pwani University and the ICT team to be able to help Florence. So, questions or reactions?
Thank you very much for the wonderful presentation. From a layman's perspective, a smallholder farmer who wants quick fix solutions to the problem. You've indicated that this study has now moved to another level and whereby there's another breeding program for further improvement. So is there light down the tunnel, and how long will it take for this new variety which can address the GLS disease to be out?
Thank you, Daktari. Now I'm doing F3, and with the new technology of biotechnology, molecular analysis, I don't need to go further. I need to do molecular analysis where I will be able to see the genes. So when you see the genes at F3, because for release of variety, you need to go around 6 cycles. That's around 6 years. But now with biotechnology, that's the next objective I'm doing right now. I'm looking at the gene level at F3 and F2. F2 vis-a-vis F3. These genes will show me this variety, whether it's resistant or susceptible. So I'm going to reduce the cycle by almost half.
Thank you very much, Nicholas. I think we give him a hearty clap again. 1, 2, 3. Okay, asante sana. I hope Florence from Pwani, Kasungu, you are online. Kasungu, ICT, do you see Kasungu, Florence? If not, then we go to Is Kasungu on, please, ICT? Kasungu, Florence from Pwani. Florence from Pwani, are you on? We can't hear you, Florence. We can see your screen sharing. Florence. Hello, Florence. Are you on? ICT, any response? We can continue with the next one as we hold our... Okay, we can move on to the next one. And that is Mercy. Mercy, please take the podium. 10 minutes. Mercy, you are right in your time. Good. You can continue.
My name is Mercy Mikali from Egerton University. I'm undertaking MSc Food Science, and I'll be presenting my findings on probiotic properties and safety profiling of Lactobacillus plantarum, isolated from spontaneously fermented milk amabere amarorani. Well, we might ask ourselves, what are probiotics? Maybe you have heard somewhere people are campaigning about probiotics. They are live microorganisms that, when administered properly, they confer health benefits to the host. Well, fermented foods with these live probiotics, they are considered as functional foods, as these probiotics give us beneficial therapeutic effect to our bodies. Some findings have suggested that probiotics, they have anti-cancer effect. Some have suggested that they reduce the cholesterol level in our bodies. Others have been found that they reduce infection, GIT infection in our bodies. So they have many benefits that are still being tested. And among these probiotics, mostly we have bifidobacterium and lactic acid bacteria. Well, they have been used both in animals and in human beings. Lactobacillus plantarum is one of the lactic acid bacteria that has been widely studied and used in production of fermented foods. Well, in our nation, fermented foods are spontaneously produced. Well, these have, you find that these products, they have inconsistent quality. So they pose danger to our bodies because they are not controlled. So coming up with the probiotics that can be used as starter cultures for these fermented foods will be very beneficial. We find that there are many isolates that have been isolated from locally fermented foods, but they have not been made to commercially probiotics that can be used to production of these fermented foods. Well, in our study, in our present study, we evaluated the probiotic properties and determined the safety profile of this Lactobacillus plantarum isolated from the Kenyan fermented milk. Well, there are guidelines that have been outlined by FAO and WHO to which we can undertake this, we can be able to evaluate these probiotic properties. Number one is the GIT survival. Our body is meant in such a way that it is meant to protect itself. Number one is the survival of the stomach acid, which is a very harsh environment. A probiotic should be able to to survive this environment and colonize the GIT and be able to give us these benefits. Also, they should not have antibiotic resistance, and also they should have an antimicrobial activity. In our methodology, for the probiotic properties, we checked for the temperature sensitivity at these different temperatures. We checked for acid tolerance. We also tested for phenol tolerance, 0.4%. We also did antagonistic activity. For the safety profiling, we did hemolytic activity and antibiotic susceptibility against different antibiotics. To our results, there have been numerous attempts to have these locally isolated microorganisms to be isolated so that we can measure their benefits to our bodies. And so, in our temperature, we checked the temperature so that we can know that they can be able to survive the body temperature and also to know their condition during industrial production. So, the temperature for the Lactobacillus plantarum, it was found to survive well in 30 degrees and 37 degrees Celsius. Its viability decreased at 20 degrees and 45 degrees. Its optimal temperature was 37. So this showed that it could survive the body temperature. For the acid tolerance, for it to be able to survive the stomach acid, normally the standard is pH of 3. For as you can see from the line graph there, the Lactobacillus plantarum, with the increase in pH, it was able to, its viability decreased even though not to 0. Some of them were able to survive. And these few that survived can be able to colonize the GIT and be able to accrue these benefits. For the phenol, the reason why we did phenol, there are toxic metabolites that are produced in the intestines as regular bioproducts of aromatic amino acids. And this affects the probiotics in that they have bacteriostatic effect and they can hinder this microorganism from growing. And so for the Lactobacillus plantarum, you can see from the control and the one that had 0.4% phenol, they had no much difference. It's actually tolerant to 0.4% phenol. For the antagonistic activity, we can see that we tested the Lactobacillus plantarum against Salmonella, Escherichia coli, Staphylococcus aureus, Candida albicans. These are pathogenic microorganisms that people normally got foodborne disease from. So, as you can see, Lactobacillus plantarum was able to reduce these microorganisms, to be able to hinder their growth, starting with Salmonella, and Candida albicans was a bit resistant. So this is very important when it comes to protecting our GIT from pathogenic infection. Like just now we have come from taking lunch. You don't know whether that food has some pathogenic microorganism inside. It's just trust and have faith that you'll not become sick when you have eaten that food. But when you have this probiotic microorganism, they are able to hinder the growth of this pathogenic microorganism and maintain a healthy microbiota. And also when we use them for fermentation, they are able to increase the shelf life and also reduce food spoilage. So for antibiotic susceptibility, we tested about 7 antibiotics. There have been some researchers have said that probiotics should be resistant to antibiotic in that when you consume antibiotics, when you are sick, they are able to survive. But now there is another question whereby what if these microorganisms are able to pass gene resistance to other pathogenic microorganisms and they are able to dominate our GIT. So there is that conflict, and so it's safe to say that the Lactobacillus plantarum, it was sensitive to most of these antibiotics. You can see, for example, anthromycin, ciprofloxacin, these are tetracycline, gentamicin, chloramphenicol. They are most common antibiotics that we use. This is a picture. For the first photo, it's for nalidixic acid. It's an antibiotic. You can see the lactobacillus was a bit resistant. The second one was for tetracycline. You can see it was really hindered. You can see that space there, the zone of diameter in inhibition. It's quite large. So for safety profiling, we did hemolytic activity, whereby we checked whether this probiotic microorganism has any virulent factor or is it pathogenic. And so for a probiotic, it should not be able to hemolyze blood or have any virulence factor. And so for the Lactobacillus plantarum, it was shown that it did not have any clear zone. When we stripped it, you can see from the petri dish, or no greenish zone was observed. So in this case, we say it is not virulent. It had gamma hemolytic activity. In conclusion, this study demonstrated that Lactobacillus plantarum is an excellent probiotic candidate. It exhibited high potential owing to its high resistance to pH, to temperature, to phenol, and its antibiotic susceptibility, and also its ability to be able to prevent the growth of other pathogenic microorganisms. And so with this probiotic Lactobacillus plantarum, we can be able to use it as a starter culture to our local fermented foods. And so, but this study was a bit limited, so there is need for more probiotic parameters, and in vivo activity of the isolate should be investigated to validate its immunodilatory, nutritional, and health benefits. And I would like to acknowledge the first person who did isolate this microorganism, Mr. Sichangi, and also my supervisors, and CISAM for funding my work through World Bank. Thank you very much for listening. God bless you.
Thank you very much, Mercy, for that very wonderful presentation. And without further ado, we want to welcome the audience if you have one or two comments, and also those who want to present them in the chat, and to continue interacting outside maybe this session through the chat. So one or two questions. Okay, thank you very much, Mercy. That was a wonderful presentation, and we hope that the yogurt that we took at lunch hour had a bit of that. So we go on to the next one. I will invite Carol, if she is around. The ICT, you can be looking for the two presenters from Pwani, either through phone, and if they are ready, then we can go straight on to them. Pwani, just hold on, we'll come back to you. As this one, let one of those who are physically here present, we'll come back to you. Pwani. Pwani, I'm told the physical presenter is not yet linked. Can you go ahead, please? Okay, you will share in a moment. Just connecting. We can see your screen. Would you mind going on ahead 10 minutes, please, and 5 minutes for interaction?
My supervisors are Dr. Esther Mwindi, Dr. Mlinge, and Dr. Wamkota. My title is Performance of Selected Sorghum Varieties on Titanium Mined Soils in Kwale County, Kenya. Sorghum is the world's fifth most important cereal grain after maize, rice, wheat, and barley. It is a native tropical crop. It is a native to tropical Africa. It is widely produced in the tropical, semi-tropical, and arid regions. It has the ability to withstand harsh conditions, and it serves as the main staple food in the poorest world, and also the food is the poor population. Due to these characteristics, it is referred to as a camel of the plant kingdom. It has 4 categories, that is grain, which is used as a staple food in the tropical areas and also a raw material for making beer. The broom category is also used for making brooms. And then we have the sweet and grass category, which is used for making sweetened syrup and green feed. This study was carried out in a mining company. As we know that mining is a crucial in our countries, or for it promotes the economy of the country by providing some employment opportunities. However, on the other hand, the mining processes have some negative effects on the environment, as it degrades land of its original productive value. Mining processes also destroys the ecosystem by displacing the inhabitants and altering the soil profile. This will lead to nutrient and carbon pools depletion, microbial ecosystem destruction, and moisture holding capacity interruptions. After mining, as I said, Best Titanium Limited is a mining company. It uses a method that does not use chemical to destroy the environment or to cause pollution to the environment. After mining, the company fills the mined areas by compacting soil layers to ensure stability, and after that, a thin topsoil layer from the original soil is spread on top. compacted layers hinder root from penetrating into the lower horizons, and also it will hinder water infiltration. Hence, these conditions can lead to waterlogging conditions in the short run. As we know, in these coastal soils, which is especially Kwale County, it is sandy textured. Sandy soils also pose more problems due to poor water holding capacity and stability. Therefore, successful reclamation in such soils will require proper irrigation regime and also good choice of plant species. The Base Titanium Limited land in Kwale was initially an agricultural land under crop production. So this study was carried out to evaluate the potential of titanium mined soils to support sorghum production, thus promote food security in the area. We go to the objective. My main objective of carrying this experiment was to investigate the potential of titanium mined soils to support sorghum production. Methodology. The experiment was carried out in Base Titanium Limited, Kwale County at the Southern Dune. Experimental layout, design and crop husbandry. The treatments were laid out in a randomized complete block design with a split plot arrangement and replicated 3 times. The treatments include the varieties, that is 2 sorghum varieties, Sila and Gadam, and the amendments include the farmyard manure, DAP fertilizer, DAP plus farmyard manure, and the control. Methodology, we have the agronomic practices. Weeding is very crucial in sorghum production, as weeds compete with crops for nutrients and water during this period. So weeding was done after 6 to 8 weeks after germination. And also there's a second agronomic practice, that is thinning. Thinning was also done 2 to 3 weeks, as also the plants compete themselves for nutrients. Pest and disease control. This was applied when there was an economic threshold of about 10% infested plants in a sorghum field. And in my case, the pest that was a challenge to this study was the armyworm. And I sprayed Confida 500 mils per 20 liters of water. Methodology, we have data collection. There was initial and final soil sampling per plot for about 0 to 30 centimeters depth. And also plant growth parameters, where I took plant height, number of leaves, and other growth parameters that is not in the other document. And also we have the yield parameters, where we have the weight of sorghum grains. Data analysis. Data was subjected to analysis of variance using Genster statistical software and means of separated using the Duncan New Multiple Range test of 5% level of significance. Soil analysis. This is the soil analysis table. The initial soil, after analysis, we had phosphorus. We tested the pH, where it was optimal. Phosphorus was low, potassium was low, calcium was optimal, and nitrogen was also low. Results. The effects of the treatments amendments on growth of 2 sorghum varieties. I used plant height to compare the 2 varieties, and that is, we have a table there of the amendments from week 1 to week 7. We have control, manure, fertilizer, and fertilizer. Looking at the table there, we can see at the panicle height, which is another growth parameter. Using the same amendment, we have to control manure, fertilizer, manure and fertilizer. On the table, we also have the panicle height being high on the plot with manure and plus fertilizer, followed by fertilizer, then manure and control. There we have the graph for the panicle height in the Sila variety. The panicle height with on the Gadam variety, also we have a table there from week 8 to week 12. That is when I started collecting the panicle height data, and also down there we have the graph. Effects of the amendments on the growth on the panicle height. The plots with manure plus fertilizer recorded high panicle height in both varieties, with control recording the lowest panicle height. Then effects of amendments on yields. We compared the Sila variety and the Gadam variety on all the treatments, where we have control manure, fertilizer, manure plus fertilizer. And looking at the yields on the Sila variety, we have the plots with manure plus fertilizer giving us the high yields, while the control plots give us the lowest yield. Also on the Gadam grain yields, looking at the table, we have the manure plus fertilizer plots giving us the highest yield and the control giving us the lowest yield. Conclusion. Growth and yield data collected showed that optimal use of manure plus fertilizer can support optimal sorghum production in these soils. Recommendations. The use of manure plus fertilizer can support optimal sorghum production in soils. Further research is required to investigate on the tillering ability of sorghum to increase yield and long-term production of sorghum to promote sustainable soil development in food security in the country. Thank you. That is the end of my talk.
Thank you very much, Florence, for that very informative presentation. We now take one question that may be burning from the audience, physically here, Trikipia. And if not, then we'll request if others, they can post them through the chat box. Any burning question? Okay, thank you very much, Florence. You can continue checking in the chat box if there will be any query or reaction that you can respond to. I now get back to, okay, sorry for that. Let's give her a hearty clap. 1, 2, 3. Thank you. So I revert back to Carol. If you are ready now, as we ask Mercy to be on waiting.
My name is Carol Mutua from Egerton University, a PhD student in horticulture. I'm going to present just one objective from my work, titled Micronutrient and Vitamin C Content of Pepino Melon as Influenced by Growing Environment and NPK Fertilizer Rates. I'm going to